In this video, psychrometric charts will be discussed. Also, I will be discussing how the different psychrometric properties are read from this chart. Here is an image of a psychrometric chart. If you have not come across a psychrometric chart, at first look it may seem as if a lot is going on. However, once you are familiar with it, only two known properties can be used to find all of the properties for the given state of moist air. The psychrometric chart represents the thermodynamic properties of moist air graphically. The psychrometric chart is bound by the dry bulb temperature, specific humidity, and the saturation line. Though the most commonly used psychrometric charts are those developed for atmospheric pressure at sea level and for temperature range from 0 to 50 degrees Celsius. However, ASHRAE has also developed psychrometric charts for other conditions required for different applications of AC systems. Let us now break down the psychrometric chart shown on the screen into its components. Here we can see the skeleton of the psychrometric chart. The horizontal axis is the dry bulb temperature. Dry bulb temperature is the temperature of air measured with an ordinary thermometer. The constant dry bulb temperature lines are the vertical lines shown in the figure. The vertical axis is the specific humidity, which is also known as humidity ratio. The constant specific humidity lines are the horizontal lines shown in the figure. Then there are curved lines which represent the constant relative humidity. Its value increases as one moves from right to left on the psychrometric chart. The psychrometric chart is bound by the saturation line, that is 100% relative humidity line on the left. On the horizontal axis, the value of relative humidity is 0%. Then we have a set of slant dashed lines shown in the figure, which give us the value of constant specific volume. In addition to this, we have another set of slant lines shown here as solid lines, which give us the value of enthalpy. These lines are lines of constant specific enthalpy. Let us now see how the different properties are read from this chart. Let us consider a point A as shown in the figure. Now, if we drop a vertical line from this point on the horizontal axis, it will give us the value of the dry bulb temperature of air. If we draw a horizontal line, it will give us the value of specific humidity on the vertical axis. If we again draw a horizontal line, but this time moving leftwards, it would intersect the saturation line, and here we can read the dew point temperature of air. To find the value of wet bulb temperature, we have to move along the constant enthalpy line towards the saturation line. The relative humidity is read from the curved lines on the figure. If the point on which we need to find the values of psychrometric properties do not fall on the lines drawn on the chart, then the value is found using the values of lines on either side of the point by interpolation. All these properties that we have read on the psychrometric chart have been discussed in details in the previous video. Here we have two photographs which show two different types of psychrometric charts. The one on the right has a protractor drawn on it. This protractor gives us the value of sensible heat factor, or the ratio of sensible heat to the total heat. Similarly, on the chart on the left hand side, we have an additional axis which gives us the value of sensible heat factor. Now let us have a closer look of these two charts. Now if we look closely, we can see on this axis the values have different slopes. So when the sensible heat factor is 1, the line is horizontal. As the sensible heat factor increases, the slope keeps on increasing. The sensible heat factor will be discussed in detail when we will be discussing cooling and dehumidification. However, in the meantime, we can understand how this property is read on the psychrometric chart. So say the sensible heat factor for a process is 0.45. In that case, we'll draw a line parallel to this regular slope shown here, passing through the required points. Similarly, in the chart on the right hand side, we have a semicircle on which these values are drawn. Thank you for watching.